Okay, in this video, I'm going to review some of the problems from homework set number 4. I'm not going to go all of them. I'm going to go through from problem number 7. So number 7 is about a Bengali problem. Um, and there's a voiceless dental stop and voiceless retroflex stop. So dental, T with small diacritic below it, and retroflex stop that has a little bit of little hook over here, a kind of long hook at the bottom. So there are two different stops. Both are kind of correspond to T sound in English, and they're looking for the problems looking for the distribution of these two T's and want to see if they are two different phonemes or two different allophones of a single phoneme. Okay, um, so we can see that this dental T exists in this, and this word of tune 7, small and 10, and the retroflex stop exists in these words: endure, shout, pile of bricks, and pull. And the first thing you have to do is to find if there is a minimal pair. Minimal pair is a pair of two words that sound the same except one segment, but they mean the different thing. So you can see if let's see if there's a minimal pair for ton. The hypothetical minimum pair for this would be T with retroflex T instead of dental T. That looks like this. And look at the list if there exists. Yeah, it's here. So without even looking at the other part of the data, we already found a minimal pair of these two T's, the vocal tune and to pull. So the distribution of these two T's are contrastive, not complementary. And looking at the environment, we find a minimal pair. That is vocal tune and pull. Therefore, T and dental T and retroflex T are separate phonemes. That will be the easiest example of a phonemic analysis because we've already found a minimal pair, and we can move on. Number 8 is about a certain dialect of English that is spoken in Boston and Southeast England. There is two different R's here: a usual R sound and rounded or labial R sound with R with a diacritic over here. So let's see if these two are allophones or different separate phonemes. So the first R exists here, 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 and here. And at the right side, it's over here and here. For R with a labial or rounded R, it exists here, 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 and all the words around at the right row. So let's see if there is a minimal pair for this. Is there a minimal pair for corresponding minimal pair for this? So for example, like this. No, there's no minimal pair for this. Trim. Is there a corresponding pair that looks like this? No. So we can check. Free. Is there free? It's a fear, so it's not this. Meyer with W? No, there's no. Eerie without W? No, there's no such thing. Approve without W? There's no approve without W. Wharf with W? There's no such thing. Sure with W? No, there's no such thing. Turmeric, turmeric without W? No. Um, break without W? No. Replay without W? No. Rent without W? No. Ascribe without W? No. Crust without W? No. Hardly with W? No, there's no such thing. Fear with W? No, there's no such thing. So we can conclude that we could not find a minimal pair of these two sounds. It does not automatically mean that these are allophones. We have to still look into it if we can find a rule that describes the environments that these two allophones, hypothetical allophones, can exist. So for the first R without W, let's see what kind of environment it is in. So it's in this Meyer. It's also at the end of a word. Wharf between O and F. Sure between U and word final position. Hardly, that's between A and D. And fear. So there are 6 non-overlapping environments we've already found. Let's see for the R with W. So it's a labial or rounded R. Trim between T and E. Free, F and I. Eerie between dotless I and dotted I. Approve between P and U. Turmeric between A and E. Break between B and A. Reply, word initial position. Rent, also another word initial position. Ascribe between K and A. Crust between K and A. C, if we've already found the whole total list of all the environments that these two sounds can exist. And let's see what we can generalize out of this list. So if we see the first part, the left part of the environment, in the first list, there's a bunch of vowels. Maybe the defining feature of this list is that the environment is after a vowel. But if you see the second list, there is a word that starts where there's an environment that is after a vowel too here in this list. So it may not be the case the left part of the environment is the determining feature of this list. But if you see the right part of it, you can see there's no vowels around here. It's either word final position or consonants F or D. But on the other hand, the right side of this list, it always ends with a vowel. So easily we can find out, we can generalize these two lists, that the second list can be generalized as an environment before a vowel, while the second list is either before a consonant or word final position. So which means they can be summarized into elsewhere environment. Therefore, we can set this, we can say that these two lists of environments do not overlap. And there is a certain rule that determines which allophone to come out. So they are in a complementary distribution. Therefore, they are two different sounds, two different allophones of a single sound. And always the elsewhere allophone is said to be the default phoneme. So we can say something like this. And then we write a rule. This phoneme is realized as labial R, where they are before a vowel. That was number 8. So distributions are complementary. Looking at the environment, we find that labial R exists only before a vowel. Therefore, they are a single phoneme. Allophones of a single phoneme. Done. Number 9. It's about a Mandarin Chinese. Mandarin Chinese is a Sinitic language spoken in China and by Chinese diaspora around the world. You can see the list of words. So they are the sounds of interest is S and X. The S sound is alveolar fricative. X is a velar fricative. They are both voiceless. Let's see which one has S, which one has the X sound. So here, sweep, and 30 and fast. Sao, sa, and su. And for X, it exists in the words like clam. Oops. C is right. Clam, ha, hao, and shu. Oh, sorry. Hu. There are 3 words that containing the velar fricative sounds: ha, hao, and hu. And 3 words containing S sounds: sao, sa, and su. Let's see what the environments are. So for the S, it exists before a, u, ao, all of them word initial. X exists before a, u, and ao, all of them both word initials. So basically, we didn't have to do this because there is an overlapping environment. The first step of the phonemic analysis is to find a minimal pair. So we've already found a minimal pair like ha and sa, sao and hao, and su and hu. There are 3 sets of minimal pairs in this word. You didn't have to do this. Sorry, I was getting distracted. So we've already found a minimal pairs. There are 3 of them actually. Minimal pair of clam and 30, beard and fast, and good and sweep. So looking at the environments, we find a minimal pair. Therefore, they are in the contrastive distribution, and they are separate phonemes. Let's move on to the next question. Refer to the Mandarin Chinese data above, and this time we see alveolar S and alveolo-palatal fricative sha sound. So let's go back. This time we're gonna look at different sounds. S, which is alveolar, and sha sound, which is alveolo-palatal. So sha exists here, 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 here. It sounds xiao, xia, xi, and xu. While s exists in here, sao, sa, su. So basically, a, u, ao, while sha sound exists before ya and e here, and before u, which is a closed front rounded vowel. So basically, there is no overlap between two different lists of environments. They are all starting with this pound sign, which means they are all word initial position. So word initial position is not the feature that is defining a sublist of these two. So basically, the second one start always the environments are before e or we. They're both high vowels, the closed vowels, and ya sound, palatal consonant. Sometimes it is called a semi-vowel that resembles the sound of e, because e, ya sounds ya. They're very similar two sounds. So they are often together grouped. And while here, u, they're both back vowels. You can see, you can find the defining feature of each list. I don't know what the candidate answers in this problem. I will check later. But anyway, I think the answer was that the alveolo-palatal sound, sha sounds, only exist in a front vowel before a front vowel or ya sound, which are often together grouped as a natural class that triggers a palatalization. So alveolar sounds becoming palatalized into an alveolo-palatal sound. So the default phoneme is S. They are realized in two different sounds, two different allophones of a single phoneme. The realization of being the sha sound occur only when it is before a front vowel, e or u, or the palatal consonant, ya. So that was problem number 10. Let's move on to the 11, 12, 13. When a child says mado instead of tomato, some part of this word is eliminated to become mado, right? That's deletion. When a child says blue instead of blue, there is a new segment schwa inserted before b and l. Insertion is called apenthesis. Number 13, a child says cook instead of cook. So the right word is cook, but the P becomes K, and it is not metathesis. No order is changed. It's not deletion. It's not insertion. It's a change from P to K because there's K over right here. It is becoming closer. It is becoming similar to a sound, to a neighboring sound, K. So that's why this last phenomenon is categorized into assimilation. Okay, that was problem 13. Thank you very much.